All right, so now we are starting chapter 4, and chapter 4 covers a new concept, and that concept is integration. And so the first section, 4.1, covers what antiderivatives are and an indefinite integration. So this first video is going to cover the concepts, and then the following videos will do examples. So up to this point in this course, I said there were three main topics. There's limits, derivatives, and integration. So we've dealt with limits and derivatives, now integration. And it's for describing integration, I'll go based on an example. And for this example, suppose you wanted to find some function, capital F of x, whose derivative is lowercase f of x equal to 3x squared. So this is using a capital letter. Generally, they're going to use capital letters for what's called the antiderivative. But we're going to find this function whose derivative is 3x squared. All right, so we're going into like a reverse order from derivatives. So that is, we wish to find some function, capital F of x, where it's f prime of x, that's the notation for a derivative, is equal to 3x squared. So sometimes they'll use f prime of x in the place of lowercase f of x. A possible function could be x cubed. Right? So why that is because we use the power rule, and using the power rule that results in 3x squared, right? Because you drop down the 3 and then subtract 1 from its exponent, so it becomes 3x to the 3 minus 1, 3x squared. So a possible function whose derivative is 3x squared is x cubed. But that isn't the only function. We could have the function be x cubed plus 2. Right, because the derivative of a constant is 0, so whenever we find the derivative of x cubed plus 2, you'll get 3x squared plus 0, because 2 is a constant, so that's derivative of 2 is 0. All right, so that gives us 3x squared. You can also have another function, say x cubed minus 2/3. Now, because 2/3 is a constant, or minus 2/3 is a constant, its derivative is 0. So you get 3x squared plus 0, which is 3x squared. So I put a table here, and for the first column, that's capital F of x. And these are the three types of functions whose derivative is 3x squared. So they all have that same 3x squared for the derivative. And that's called f prime of x, using the capital letter f. And they were x cubed plus 2, x cubed minus 2/3. So these are just three examples for which the derivative is 3x squared. In fact, there are an infinite amount of functions where this is the case. And it's going to be any function of the form x cubed plus c, where c is a constant. All right, because that will always give us a derivative of 3x squared. Now the x cubed plus c, so that's capital F of x equal to x cubed plus c. So that general form, that's called the antiderivative of the function f of x equal to 3x squared. All right, so we're going sort of, and it's kind of like a reverse order analogy, I would say, analogous to factoring versus distributing. All right, so factoring, you want to find some factors so that when you multiply them together, you get some result. And the process of multiplying those factors that's distribution. All right, so in this sense, we're going sort of backwards from a derivative, 3x squared, and getting the original, not really, but a antiderivative or a function such that the derivative is 3x squared. And any function of the format x cubed plus c will do that. And because there's this constant plus c, and it can be any constant, any value, there's an infinite amount of possibilities for this antiderivative, like x cubed plus 2, x cubed minus 2/3, for instance. All right, so that's the idea. And so now I'm just going into the definitions. And a function capital F is called the antiderivative of some function lowercase f when the derivative capital F prime of x equals that function f of x for all x on some interval I. All right, so for our example, we had f of x, lowercase f of x being 3x squared. That's the same as having capital F prime of x. Gave us the same thing, 3x squared. All right, so that's called the antiderivative, capital F is. So this representation of capital F of x equals x cubed plus c is a representation of the family of functions, right? I said there's an infinite amount of possibilities because of the constant c can be any value. So that's called a family of functions whose derivative is 3x squared. We refer to this family of functions as the general solution. And c is a constant, and it's called the constant of integration. All right, so I haven't said what integration is yet, but c is called the constant of integration, which leads me to the next thing. The process in which we find the antiderivative is called integration. All right, so the process to finding this capital F of x, right? So the process of finding that is using what's called integration. It's analogous to like finding the derivative. It's the process in which you find the derivative is called differentiation. All right, some reason the lingo is integration this time for finding the antiderivative. All right, and a lot of the times when you're finding the antiderivative, capital F of x, it is commonly referred to as finding the indefinite integral. All right, so most of the time I will just be calling finding the indefinite integral sort of beyond this section, but it is analogous, or not analogous, synonymous with finding the antiderivative. All right, so main points, we're finding an antiderivative now. That's a new concept. It is like the reverse of finding a differentiation. The process in which we find the antiderivative is called integration. Sometimes we just call finding the antiderivative as just an indefinite integral. And when you do find this indefinite integral, it's going to be a general solution, which is referred to as a family of functions because of the constant plus c. All right, so that's the terminology. Now, notation-wise, recall that when we're finding the derivative of a function, we wrote the derivative operator as this. We had d, and then it looked like the fraction d over dx. And then we put in brackets whatever the function is that we're trying to find the derivative of. All right, that was our operator. And then after we get the derivative, we wrote it as y prime or f prime of x, or sometimes dy dx. All right, so again, this is an operator. It's not necessarily a fraction in the sense of how we look at fractions. So that was the notation we used, was d dx, find derivative of f of x. The result is f prime of x, or y prime, or the common ones I used. Sometimes they would use dy dx. So for the antiderivative, we're going to write this as an integration operator. And the integration operator is going to have this weird looking S shape symbol, elongated S symbol, and it'll have this dx. And that'll be around our function, which we're trying to find the antiderivative of. So the result is going to be a family of functions, capital F of x plus c. And so here we write it all. So we have the elongated s, and that's called the integral sign. And then we have f of x, that's what we're trying to integrate or find the antiderivative of. That's called the integrand. The dx tells us what the variable integration is. So normally it's going to be dx. We're taking the derivative or taking the antiderivative with respect to x. And same thing as just saying we're integrating with respect to x. All right, so antiderivative, same as integrating. All right, so then the result is this thing called f of x, capital F of x plus c. And the capital F of x is the antiderivative, and then c is the constant of integration. And that whole thing itself, the capital F of x plus c, is a family of functions, which is sometimes just called the general solution. All right, so I know it's a lot to pack in. Main idea is integration is like the reverse of differentiation. Sometimes we just call the antiderivative as the indefinite integral, and that involves using an integration operator, and that operator has this elongated s around our function, and then dx. And the dx tells us what our variable of integration is. The result you get is capital F of x plus c, and capital F of x is the antiderivative itself of f of x, and then c is the constant of integration. So there's always going to be a plus c after we do this, and that is always going to be the case for indefinite integration. So I'll make a note. So there's always going to be this c constant when we're finding the indefinite integral. So when finding all right, and then the indefinite integral consists of the antiderivative plus some constant. And we'll learn later on what a definite integral is. All right, so for the example that we had at the beginning, we wanted to find a function so that its derivative is 3x squared. So we would write it as, we have the integral, so the integral, that's the elongated s, so the integral of 3x squared the integral of 3x squared is x cubed plus c. All right, that's how I would say it in words. So the notation, so we have the elongated s thing, that's our operator to say we're going to integrate, and then we have our function that we're integrating 3x squared, and then the dx tells us we're integrating with respect to the variable x. All right, and then we get the result to be x cubed plus c. And that x cubed plus c is the family of functions. The x cubed itself is the antiderivative. All right, so that's basically the main points. And now, just like how we applied derivative rules to find a derivative, there are rules that we apply to find the antiderivative or the indefinite integral. So the table on Blackboard has a list of these rules, and here are some of the rules. So I put on the left the derivative formula, and on the right the integration formula. So everything that's on the left we already know. So for instance, the derivative of a constant is 0. Now notice on the right side, I have the integral of 0 is c. C is a constant, so it's kind of going in the reverse. So the integral of 0 is c because the derivative of c is 0. Now if we took the derivative of k times x, k is just a number, right? So then that gives us just k because derivative of x is 1. Now going in the reverse, if we integrate k with respect to x, that gives us k times x. Now notice I have the plus c because it can be k times x plus 3, for instance. That will still give us the same derivative of k. So again, we're going to attach this plus c because it's a family of functions and we're finding the integral or indefinite integral. All right, and these are just the rules. If you want to pause the video, you can write these down. These are in the textbook. The following videos, I will actually be just going over these rules. And so it's a matter of just referencing these rules. And the pattern is that what sort of the reverse of what you have on, so on the right side is the reverse, similar to being the reverse of what you have on the left side. This is another example, just looking at sine. The derivative of sine is cosine. So when we integrate cosine, we get sine, and then plus c. So there's some small little things you got to pay attention to. We know from derivative of cosine is negative sine, but when we integrate sine, we get negative cosine. Whereas when we take the derivative of sine, it's positive cosine. All right, so that's a distinct, so the difference we get here is you get positive cosine for the derivative of sine, whereas you get negative cosine for the antiderivative of sine, or the indefinite integral of sine. Okay, and so we have, this is what we get for the result of the derivative. That goes inside of the integral. And then we get tangent of x. That's our function, which we took the derivative of to get that result of secant squared. That's the relationship. So yeah, the next video is just going to be going over using these rules. And on Blackboard, you'll see that there's a table that has all of these derivatives rules and integration rules. All right, so that's where I'll stop it for this video. This is just going over the concept. And the concept is antiderivative, which is sort of the reverse of a derivative. Or like, that's what I'd say it's maybe an analogy or whatever the word is for that. And the process in which we find the antiderivative is called integration. And the result that we get from integrating is called the indefinite integral. And that indefinite integral consists of the antiderivative plus some constant. And that whole piece, the antiderivative plus the constant, is called a family of functions, which is the general solution. All right, so now we're gonna go into another video where I'm gonna go to 2 examples to make use of these concepts.